we are dealing with the disk method. We are given the problem, the volume generated by the revolving of the area between root x and the x-axis on the interval 0 about the x-axis. Now I'm going to show you how to set this up. I will not finish it, but I'll show you how to set it up so you can finish it yourself. First we would want to sketch the graph just to see what we're dealing with. We know that the root x graph looks like that. Now since we are rotating it along the x-axis and reflecting it, we would look like this. And it is called the disk method because we are taking out a disk to help us find this integral. So when using the disk method, we use pi r squared. We know that this is our radius, and that is obviously the square root of x. This is ending at 1 because our integral will look somewhat like this. And since you can take out a constant to the front, it would be and after you get this integral, you would go about finding the integral from 0 to 1 and finding the antiderivative of this. And that is how you set up the disk method. Problem number 6 is another method that we can use, but it's called the washer method. And unlike the disk method where we're taking out a disk, we will be taking out a washer. So we will be taking our big R minus our little r to find our answer. So we will be using the integral of pi big R squared minus little r squared. And our equation is find the volume generated by revolving the area between root x and the x-axis on interval about the y-axis, which is different because in the disk method we reflected it across the x-axis. So our graph would look something. There's our original root x. There's our reflection. Our big R is going to be in here, and then our little is going to be right there. It's going to be our radius, and we're going to have another radius. So since r equals 1, we get the integral and after this is set up, you can integrate it from 0 to 1 and find your answer. Now I've shown you 2 ways to set up the disc and the washer method. Problem number 7, we are using related rates. Okay. We're saying, suppose the base of the triangle is increasing